Section 8.2, Trigonometric Ratios. The objectives of this lesson is to find the sine, cosine, and tangent of an acute angle, and to use trig ratios to find side lengths and right triangles and to solve real-world problems. The first term we're going to talk about is the term trigonometric ratio. It is the ratio of two sides of a right triangle. The three ratios we're going to talk about are the sine, cosine, and tangent. Start off, the sine of an angle is defined as the ratio of the length of the opposite leg to the length of the hypotenuse. The cosine of an angle is defined as the ratio of the length of the adjacent leg over the length of the hypotenuse. And the tangent is defined as the ratio of the length of the opposite leg over the length of the adjacent leg. Here's the right triangle. We all know that the length of the hypotenuse is the side that's opposite the right angle. So AC is my hypotenuse. And the other sides, the opposite and the adjacent, depend on which angle we are talking about. If angle A is the angle that I'm working with, the side opposite angle A would be BC, and the side adjacent to it would be AB. Remember, adjacent is next to it. However, if I was looking at angle C, the side opposite angle C would be AB, and the side adjacent to angle C would be side BC. Now we're going to get some practice with that, and it's going to make a lot more sense in just a minute. There is an easy way to remember all of this information when working with these trig ratios. It uses the first letter of the ratio and the first letter of each specific side in the ratio. Okay, when you put that all together, we get SOHCAHTOA. SOHCAHTOA. Remembering the phrase SOHCAHTOA will help you remember the trig ratios every time you work these types of problems. Let's get some practice doing that. One more thing before we move on is that these trig ratios are often abbreviated. SIN for sine, COS for cosine, and TAN for tangent. And just a reminder of how we use these trig functions. If I were going to find the sine of angle A, I'm going to use this SO, my SOHCAHTOA. The sine of angle A is the opposite leg over the hypotenuse. I'll just write that. Opposite over hypotenuse. Now in my right triangle, I know this is my hypotenuse. And if I'm looking at angle A, the side opposite that would be BC. Side BC over the length of AC, my hypotenuse. To find the cosine of angle A, I would need to use the adjacent over the hypotenuse. So the length of my adjacent leg over the length of the hypotenuse. So here's angle A. Adjacent is right next to it. So it's going to be adjacent, which is AB, over hypotenuse, which is the length AC. The tangent of angle A would be opposite over adjacent. That would be BC over AB. Okay, those are all using angle A. That would change if I were to use angle C. My opposite side would now be AB, and my adjacent would be BC. Now let's get some practice. Okay, for our first example, we're going to write the trigonometric ratios as a fraction, and we're going to write it as a decimal, rounded to the nearest hundredth. First one is going to be the cosine of angle A. Here's angle A here. I like to circle it so I don't forget which one I'm looking at. And then I like to label my parts of my right triangle. So always know the hypotenuse. So if I'm looking at angle A, the one all the way across from it will be the opposite, and the one right next to it will be the adjacent leg. Next is, can't forget SOHCAHTOA. I'm asked for cosine of angle A. Cosine is adjacent over the hypotenuse. So in this case, it is 24 over 25. So that's my trig ratio as a fraction, and to write it as a decimal, 0.96. Let's do the same for the tangent of angle B. Okay, for angle B, here is B. So my opposite is now side CA, and my adjacent is now side CB. Hypotenuse, of course, stays the same. So the tangent of B is going to be the opposite leg over the length of the adjacent leg. It's TOA. Okay, so my opposite is 24. My adjacent is 7. If I divide that, I get that ratio is equal to 3.43. Example 2 says to use the right triangle, use a special right triangle to write each trig function as a fraction. Okay, we want to find the tangent of 60 degrees. We want to use a special right triangle to do that. So I know that I'm going to be using the 30, 60, 90 triangle if I want to do that. So I'm going to draw that 30, 60, 90 triangle off to the side. Don't forget your SOHCAHTOA. If I want to find the tangent, I'm going to use opposite over adjacent. Okay, so tangent of 60 degrees, that's this angle right here. So my hypotenuse is always the same. If I'm looking at the 60 degrees, this is the opposite side, and here's my adjacent. So the opposite over adjacent will be x over square root of 3 over x. I know that the x over x reduces to 1, so I end up with the square root of 3. Okay, let's do another one of those. Let's try the sine of 60 degrees. The sine is always opposite over hypotenuse. Again, I have x over x, that reduces to 1, so I'm left with the square root of 3 over 2. Okay, in example 3, we're asked to do the same thing using a special right triangle. This time we're asked for the cosine of 45 degrees. So we're going to use the other special right triangle. I need to remember my SOHCAHTOA and see that cosine is adjacent over hypotenuse. So we'll look at the length of the adjacent leg over the length of the hypotenuse. I know this side has to be the adjacent, because the hypotenuse is always the leg across. That reduces to have 1 over the square root of 2. And since we never keep the radical in the denominator, to rationalize the denominator, I multiply by the square root of 2 over the square root of 2, and that gives me the square root of 2 over 2. In example 4, we want to use the calculator to find the trigonometric ratio. We're going to round to the nearest hundredth. So I'm going to take a minute here to explain that there are a couple things you need to remember when using your calculator to find sine, cosine, and tangent of your angles. First, you need to make sure your calculator is always set in degree mode. If you don't, you'll get every question wrong. So make sure degree mode. Write it down in your notes. Next, you always need to remember SOHCAHTOA. Here's my calculator. And to set my calculator in degree mode, when you turn it on, you go to the mode button. hit the mode button, and if you go down to the third line, it says radian or degree. You're going to arrow over and hit enter so that degree is highlighted, and then you're done in degree mode. If I want to find the sine of 62 degrees in my calculator, I hit sine 62 and enter. We're going to round to the nearest hundredth, so it would be 0.88. Okay, for the tangent of 11, we get 0.19, and for the cosine of 30, 0.87. In example 5, I'm trying to find the value for x, just the length FD of this right triangle. So I'm going to use the trig function to do that, but I have to determine which one I use to set up an equation to find x. So let's look. This is the angle I have to work with. It's the 51-degree angle, which is the opposite. So then I go to my trig functions. Which one uses opposite and hypotenuse? The sine function does. The sine of 51 degrees is 17 meters over x. So I'm going to get x out of the denominator, multiply both sides by x. And then since I'm trying to get x by itself, I will divide by the sine of 51 degrees. Now, I wait till the end to use my calculator. So to put it in my calculator, I have 17 divided by the sine of 51 degrees. And I get that it is 21.87 meters. On example 6, I'm trying to find side ST, and I'm given angle T, which is 42 degrees, and the hypotenuse, 9.5. Don't forget, you need to remember SOHCAHTOA to determine which trig function you're going to use. In this case, so I'll go look and see which one of these uses hypotenuse and adjacent, and that will be the cosine. And I'm trying to get x by itself, so I'm going to undo this division by 9.5 by multiplying by it. Do the same thing on the other side. Okay, so pull up the calculator and just type it in. 9.5 times the cosine of 42. We are in. Okay, for the last example in this lesson, we're going to do a little word problem. It says, on one of the steepest railways in the world, its steepest section makes an angle of about 25.6 degrees with the horizontal and rises about 0.9 kilometers to the nearest hundredth of a kilometer. How long is this section of the track? Okay, the best way to attack this is to get a visual. So let's draw a sketch. And we're asked to find the length of the track. The length of the track will be this distance here. Let's just call it x. So all we have here is a right triangle. We've got to use our SOHCAHTOA to find the missing length by setting up a ratio. All we have for tonight. Make sure you come to class tomorrow with your notes, ready to ask questions and get started using trig functions. See you tomorrow.